In this lesson, we're going to look again at the equation of a circle, and this time it's the general equation of a circle. Now, the previous equation that we looked at was x minus a all squared plus y minus b all squared equals r squared. And we can rewrite that in expanded form. So if we take an example here, we've got a circle with centre -2, 3 and radius 5 units. And we can see that that would have equation x plus 2 all squared plus y minus 3 all squared equals 25. So let's expand this and see what we can do with it. We're going to have, from this bracket here, squaring x plus 2 gives us x squared plus 4x plus 4. And y minus 3 all squared gives us y squared minus 6y plus 9. And that is all equal to 25. Now, if I bring everything to the one side of the equation now, so if I subtract my 25 from both sides, I will get x squared plus y squared, so starting with my highest powers at the beginning, plus 4x minus 6y minus 12 equals 0. And the form that we've now got that equation in is called the general equation of a circle. Now, if we were given that to start with, we would be able to work in reverse, and we would then be able to find the centre and the radius by using completing the square. So we factorised using completing the square before, so we can do the same thing here. So the first thing I'll do to work in reverse is to add my 12 to both sides. So I get x squared plus 4x plus y squared minus 6y equals 12. I can then start completing the square, so on x squared plus 4x, when I complete the square I'll get x plus 2 all squared minus 4. And when I complete the square on y squared minus 6y, I get y minus 3 all squared minus 9. And we know that that's all equal to 12. So I have negative 13 on my left hand side as a constant, so I'm going to add 13 to both sides, and that will give me x plus 2 all squared plus y minus 3 all squared equals 25. And I can then read off my centre and my radius from that. That's -2, 3, and the radius is 5 units, because that's now in a form that I recognise from before. So given what we've already learned about the general equation of a circle, we can actually use this as a quicker way to find the centre and radius. That's without completing the square every time. So you now know how it works, so we can try and find that quicker way. So what we've got here is the general equation of the circle, and obviously we had constants in here as the coefficients of x and y and c earlier on. So we've got x squared plus 2g, x squared plus y squared plus 2gx plus 2fy plus c equals 0. Now, if we subtract a c from both sides, and then we complete the square, so x squared plus 2gx, completing the square, will give us x plus g all squared minus g squared. And completing the square on the y squared plus 2fy gives us y plus f all squared minus f squared. And that's all equal to -c. If we then add our constants to both sides, that's g squared and f squared, we get x plus g all squared plus y plus f all squared equals g squared plus f squared minus c. And we know from there, folks, that we can read off our centre and our radius, because that equation is now in this form. My centre being AB, and my radius, I can see the right hand side of the equation, the radius would be the square root of whatever is here. So the centre, given what I know now, is -g, -f, and my radius is the square root of g squared plus f squared minus c. So those are really important to remember, but those are also given in the formula sheet in the exam. So you need to remember how to use them. Now, we should also note that in order for that to be a circle, the fact that we are square rooting g squared plus f squared minus c, that expression has to be greater than 0 so that it actually represents a circle. So we need to remember that as we go through. So we can't have 0 on the right hand side of the equation here, and we can't have a negative. So let's look at an example. So the first one, we want to find the radius and centre of the circle with equation x squared plus y squared plus 4x minus 8y plus 7 equals 0. So here's my equation, and here is the general form of the equation of a circle. X squared plus y squared plus 2gx, you can see that that relates to plus 4x. Then I've got plus 2fy, you can see that relates to negative 8y, plus c, and you can see that relates to 7. So I need to get my centre first. I want to find my centre, and I know that the centre of my circle is negative g, negative f. So if I firstly look, equating coefficients here, I've got 2g is equal to 4. So I can see that from this part here. G is equal to 2, but I'm interested in negative g. So negative g is equal to negative 2. And that is the x-ordinate of my centre point. This time I need the y-ordinate of my centre point. So I'm interested in negative f this time. So looking at 2f, that's the coefficient of y, and that's negative 8. So 2f is equal to negative 8, meaning f is negative 4. And we're interested in negative f. So negative f is equal to positive 4. That means the centre of my circle is negative 2, 4. Now, if you're thinking that's quite a long process and you can already see what's happening, you might notice that if we look at the coefficient of x, we are multiplying this by negative a half, and that gives us our x-ordinate. So 4 times negative a half is negative 2, and negative 8 times negative a half is positive 4. So we get negative 2, 4. So either way, if you want to go through all of this working, that's absolutely fine. But likewise, if you want to multiply the coefficients of x and y by negative a half, that is absolutely fine as well. Now this time, we want to find the radius. The radius is equal to the square root of g squared plus f squared minus c. So we know that g is 2, that's half of the x coefficient, and f is negative 4, that's half of the y coefficient. And we can see that c is 7. So we've got the square root of 2 squared plus negative 4 all squared minus 7. Now it's really important, folks, that we have the bracket around the negative 4 so that we know that the negative is being squared as well. That's a common mistake that we don't want to be making when we get to higher. So when we evaluate that, we've got 4 plus 16, that's 20, minus 7 is 13. So the radius is the square root of 13, and that's units. Okay, so those are the final answers for that question. So just now would be a good time to pause the video and take this example down in your notes jotter. So welcome back, folks, and we'll take a look at a second example here. Now we're asked to explain why x squared plus y squared plus 4x minus 8y plus 29 equals 0 is not the equation of a circle. So remember, in order to have a circle, we need a centre, which we would be able to get from this. It would be negative 2, positive 4. And we also need a radius. Now, obviously, our radius can be calculated using the square root of g squared plus f squared minus c. Because we're taking the square root, we need what is underneath the square root to be positive. So we need g squared plus f squared minus c to be a positive number. So let's go about checking that and see if that's why this is not the equation of a circle. So let's compare coefficients here so that we get values for g, f and c. So 2g we can see is equal to 4, that's the coefficients of the x term, and g therefore is equal to 2. 2f is equal to negative 8, and f therefore is equal to negative 4. Now, if we look at the radius now, we know that the radius is equal to the square root of g squared plus f squared minus c. Substituting gives us 2 squared plus negative 4 all squared minus 29. And when we evaluate what's underneath the square root, we get this negative 9. So we've got the square root of negative 9. Now, you will be aware by now, folks, that we cannot take the square root of a negative number just yet. So, because negative 9 is less than 0, i.e. g squared plus f squared minus c is less than 0, the given equation is not an equation of a circle. So just now would be a good time to pause the video before the screen goes blank, copy these notes down into your notes booklet, and make sure that you complete the assigned exercise for today.